Okay, for this section, we are going to kind of shift gears a bit and we're going to talk about something called polar coordinates. Okay, now up to this point in your math career, we have dealt with things in the rectangular coordinate system. We've plotted points, we've graphed all different types of equations and functions, but we were exclusively dealing with the rectangular coordinate system. And it is called such a thing for a very obvious reason in just a second. So if you look here on, we've got this box here. On the left-hand side, we've got the rectangular coordinate system. Okay, so imagine some point like 2, 5. Okay, well, the way we would get to this location in the rectangular coordinate system, we would start at our origin. We would go directly to the right or to the left. That's exactly how this works. You go directly to the right, directly to the left. In this case, we go to the right too. And then from here, you can only go directly up or directly down. So 1, 2, 3, 4, in this case, directly up, and this is the 0.25. And so to get from one point to another point, you're always forming right angles. You're going directly left, directly right, directly up, directly down. That's it, okay? So we call it the rectangular coordinate system because we're always creating these right angles, okay? Something very rectangular in nature, okay? And this has been really great for us. It allows us to graph all sorts of stuff. We can graph all different types of equations. We can graph functions. It's been beautiful. But we need this extra world now. We've kind of expanded to the point where we need to see new things. So we have the polar coordinate system. Okay. Now in the polar coordinate system, we kind of have a vision of it here sort of plopped on top of the rectangular coordinate system so we can kind of understand how things work. But basically you have what's called a pole. It's right here, and it acts like the origin. Okay, so it's very similar to the origin in the rectangular coordinate system. And then you have your polar axis. Well, it works very similarly to the x-axis. Okay, so you need to understand that now we have a pole, now we have a polar axis. We no longer have the origin and the x-axis, but this is all fine. Okay, now what's really cool about the polar coordinates is it opens up this new world for us. So when you get into maybe little bits of Calc 3, but Calc 2, but definitely Calc 3. So maybe Calc 2 if I remember correctly, but for sure Calc 3. You're going to need to understand polar coordinates, polar equations, all sorts of things in this new world. And it's going to make things easier for us. So there are going to be certain things that in the rectangular system we can't really graph them with ease. They're going to be just this big old mess. But once we convert it into this polar system, things are going to be nice. We can graph things that like maybe in the rectangular system aren't functions, but then when we convert them to polar, they are. Okay, the polar coordinate system allows us a lot more freedom when it comes to graphing things with circular or rotational motion. Okay, so it's really quite helpful. Lots and lots of different fields use this. So navigation dealing with sonar and radar. Okay, physics dealing with circular motion and waves. Engineering, all sorts of engineering jobs where you're dealing with like gears and motors. Okay, even computer graphics. This kind of stuff is really helpful in these real world applied fields. Okay. Now, for us at this point, we're not going to go too deep. We're just going to kind of like introduce this idea so that when you need to use it later on in your math and science career, it won't be quite a shock to you. Okay. So, the polar coordinate system, what you need to understand, kind of the heart and soul of this gives us a way to plot points using an angle and a distance. So it's going to free us up. We're going to be able to graph new kind of complicated things now. But these regular just polar coordinate points, you can now plot points. You can plot locations out in space. As long as you know an angle and a distance, you're good. Okay. So polar points look like ordered pairs. Okay. They're going to look very similar to ordered pairs, but they come to us with R, which represents some kind of a radius, which is really just a distance from the pole. That's really important. Understand that R is just your distance from the pole. Okay. And theta is just some regular angle measure. Okay. We've measured loads and loads of angles at this point. We know that if you're in the rectangular coordinate system more so, and you're thinking like standard form, the vertex is at the origin and the initial side is on the x-axis, and then you sweep in the counterclockwise direction for positive angles and the clockwise direction for negative angles. Well, now we have our vertex at a pole. okay? And our initial side is going to be at the polar axis. We still open in the counterclockwise direction for positive angles, in the clockwise direction for negative angles. So what we do is we open up some angle measure, and then we measure a distance from the pole along the terminal side of that angle, as long as R is positive. Now, if R is negative, we do a little something different there, okay? So just understand this is a way to plot points where you have an angle and a distance instead, okay? So let's look at actually plotting points. We have several points that I want to plot here. I want to make sure I don't want to take it too slow to the point of it being like just obnoxiously slow and sort of frustrating, but I don't want to speed up and just zip through this either. Okay. So steps to plot the point r comma theta. So polar coordinates come to us in the form r comma theta. You must know this. Okay. All right, so that is the format of a polar coordinate, okay? And what we do is we actually draw the measure of the angle first. So we figure how far we have to sweep and in what direction for our angle. And then the vertex, remember, that's going to be at the pole. The initial side is going to be the polar axis instead of the x-axis and the origin. We say pole and polar axis, okay? And then once you sweep open your angle, you measure a distance along the terminal side of theta to reach whatever point, okay? Now here's the catch, all right? If r is less than 0, so if r is negative, we don't measure a distance from the pole along the terminal side of the angle. We measure a distance from the pole in the opposite direction as the terminal side of the angle. Okay, so if r is positive, you sweep open your angle and you measure out some distance from the pole along that angle, okay, the terminal side of that angle. If r is negative, you measure the distance from the pole in the opposite direction of the terminal side of the angle. So that can be a little bit tricky sometimes, but we're gonna look at several examples here, okay? So ta-da, this is the polar coordinate system. And it kind of makes sense that it's going to be this circular thing because one of the things I told you is having this polar coordinate system allows us to investigate things where circular or rotational motion are involved, okay? So kind of cool the way this works, all right? But let's focus now just on plotting points, okay? So we have our pole and we have our polar axis. Now, this is not the origin and the x-axis, but they work kind of the same way, okay? So make it feel like the origin and the x-axis if you need to, but please know they're called the pole and then the polar axis, all right? So for this first point, we have 3 comma pi over 3. So the angle that we need is pi over 3, and the distance along the terminal side of this angle is 3. And since this is positive 3, we really are going along the terminal side of this angle. So what do? Well, we measure the angle from the polar axis, okay? If the angle is positive, we open in the counterclockwise direction. If the angle is negative, we sweep open in the clockwise direction. And then we figure out where our terminal side would be, and we either measure a distance along the terminal side, or remember, if r is negative, we measure it in the opposite direction. So let's do this one. So I'm going to draw some lines and then we'll erase them for each point just to make it not too messy. But let's say we need to find pi over 3. So starting with the polar axis, I want to sweep open until I get to the angle measure pi over 3. So that would be the angle measure for pi over 3. Now, the terminal side of pi over 3 would be right here. And we want to measure a distance from the pole, which remember, that's kind of like the origin. We want to measure out 3 units, positive 3, so 3 units along this terminal side. So this would be 1, this would be 2, this right here would be 3. So let me use red to mark this. So the point 3 comma pi over 3 would be located right here. So we sweep our angle open from the polar axis, pi over 3 radians, and then we measure out 3 units from the pole along the terminal side, since r was positive, along the actual terminal side of the angle. So that is how you plot that point 3 comma pi over 3 in rectangular, or not rectangular, in polar coordinates, okay? Now next up we have point B, which is negative 5 comma 5 pi over 6. So let's erase kind of like our side work, okay? All right. So we have first the angle measure 5 pi over 6. So starting at the polar axis, we would sweep open until we got to 5 pi over 6, which is right here. So our terminal side would be this dotted line, okay? But R, the distance from the pole, is negative this time. So we don't want to measure our distance along the actual terminal side of this angle. We want to measure it in the opposite direction. Okay, so if this is our angle, the opposite direction is going to be down here. And we want to measure out 5 units in the opposite direction of our terminal side. So we've got 1, 2, 3, 4, 5. So let's plot this point, and we're going to call this point B. Okay, so that is the polar coordinate point, -5, 5 pi over 6. Okay, so understand that from the polar axis, you open up whatever angle, you figure out where your terminal side is. If R is positive, measure out that many units from the pole on the terminal side. If R is negative, from the pole, go the opposite direction of the terminal side. Okay, now let's erase our side work again. We're not trying to gum this up too much. All right. So now let's look at point C. So for point C, we have 4 comma -pi over 2. So the angle is -pi over 2, and then R, the distance from the pole, is 4. So from the polar axis, now remember, negative angles we open in the clockwise direction. So I'm going to kind of sweep down from the polar axis. I'm going to sweep down until I get to what would be -pi over 2. This would be -pi over 2 radians. Okay, so this would be the terminal side right here, this dotted line. I hope you can see it. All right, and we want to measure out 4 units from the pole along this terminal side. Since R is positive, we're going to go on the actual terminal side. So let's see, we've got 1, 2, 3, 4. Let's go ahead and mark that with red, and we'll say this is point C. Okay. So hopefully this isn't too bad. I hope you understand what we're doing here. Remember, sweep out your angle, whichever direction for positive or negative. If R is positive, measure out that many units from the pole on the terminal side. If R is negative, measure out that many units in the opposite direction from your terminal side. All right, let's look at point D. So again, I'm going to get rid of some of my side work here. Okay, point D is -6 pi. This is probably the weirdest one. Now, we know that pi radians is all the way over here. Okay, so this is the terminal side. All right, so we've swept open some angle, pi radians. We've got our terminal side and dotted in this like little dotted line, but our R is -6 here. So that always tells me that I want to go out however many units in the direction that is opposite the terminal side. Well, opposite the terminal side is going to be over there. So from the pole, we want to go along the polar axis. We want to go out 1, 2, 3, 4, 5, and then 6. So we're going to plot this point and we're going to label it point D. Okay, so that one's a little weird because the pi radians makes it like what would ordinarily be the negative x-axis. And then when we go in the opposite direction, we're just sort of back on the polar axis. But that's how this one works. Okay, so let's get rid of our side work again. I accidentally got rid of my whole polar axis. Let's put it back. Okay, now for point E, we have 2 comma 5 pi over 4. So the angle that we need to sweep out is 5 pi over 4. And then because 2 is positive, we're going to go 2 units along whatever that terminal side is. Okay, so from the polar axis, we're going to open in the counterclockwise direction, and we're going to go to pi over 4, which is right here. Okay, now because R is positive along this dotted line terminal side, we're going to plot out 2 units. So from the pole, we're going to go here and then here, and we're going to plot it in red and make it official. So this is what point E. All right, so sweep out your angle and then go however many units from the pole on the terminal side if R is positive, in the opposite direction of the terminal side if R is negative. All right, let's erase our side work again. And let's look at point F. So point F, we have -3 comma 2 pi over 3. So the angle that we need to sweep open is 2 pi over 3. So from the polar axis, we want to open to here. All right, this is our terminal side. But in this case, R is negative. So we want to measure out 3 units in the direction that is exactly opposite our terminal side. So if our terminal side is here, we want to actually measure out this like crazy looking dotted line that I have in quadrant 4. Okay, so I want to measure out 3 units. So 1, 2, 3, and let's label this point F. Okay, So just remember, if R is negative, you always go directly opposite your terminal side and then measure out how many units. Okay. Now, last up, we have point G, which is 3 comma negative pi over 3. Okay. So let's get rid of some of our side work so we have a clean slate to work with. All right, so negative pi over 3 from the polar axis, we're going to sweep down pi over 3 radians. So that would be, whoops, let me get my marker. That would be to this point right here. All right, so this is going to be my terminal side. And R is positive, so we want to measure out 3 units. So that's going to be 1, 2, well, I'll be daggum, look at that. Let's plot this one in blue just to make sure it stands out from the rest. So what do you notice? This is part H of this. It says, what do you notice about points F and G? Well, they're the same. They represent the exact same location. And that's something really, really important to understand, okay? In the rectangular coordinate system, each location in the rectangular coordinate system was represented by exactly one ordered pair, one XY ordered pair. But in the polar coordinate system, we have infinitely many different coordinates that'll represent the same location. And it's all about that cyclical, like not cyclical, I don't know if that's the right word, but it's all about that periodic nature of our trig functions. Okay. So when we measure out, along the unit circle, if I were to look at this point, like right here, okay, so let's say we're at 5 pi over 6 radians. If I went another 2 pi radians, I end up right at the exact same spot. If I went another 2 pi radians, I end up at the exact same spot. If I subtract 2 radians or 2 pi radians, I end up in the exact same spot. So it should sort of make sense to us that there are going to be infinitely many sets of coordinates that represent the same location. Okay, so we will focus on that in our next video. Okay, so this example of F and G was just kind of a taste of what we need to understand in our next video. So this video is just about what is the polar coordinate system, when is it useful, and how do you plot points. In the next video, we'll look at that situation where, hey, we have multiple coordinates that represent the same spot. Okay, so that's it for this one. We'll look into this a bit deeper in the next video.